I'm a man with a mission.
The Moths of Programming,
I'm a man with a mission.
a podcast series by Dino Dini. Chapter 1.
I'm a man with a
Global
mission.
variables are bad.
I'm a man with a mission.
Unfortunately, it is a feature of humankind to often grab hold of an idea and propagate the idea, clinging on to it in the same way as, I don't know, a warring party of a nation might fight a war with another nation, and the raging war might take place for years, decades, until eventually nobody remembers why they're fighting anymore. And this sort of happens in software engineering, computer science. And one of the examples I'm going to give, because this is what this whole series is about. It is about the moths of programming and the desire to clear them out. So the example I'm going to start with now is global variables. There is, in the kind of consciousness of programmers everywhere, an idea that global variables are bad. And like all such things, there is a truth to it. There's a reason why this idea came about. But now people are fearful of global variables, but they don't really know why. So I'm going to examine that right now. First thing to realize is that if you haven't had experience of programming in its various forms throughout history, then you do not fully understand why we have come to believe the things that we believe. We could say that in essence, the problem with computing and computer science comes down to this at a fundamental level, that we do not historically pay attention to the things that have been discovered before. The result of this is quite tragic, because it means that from the consciousness of programmers, there escapes the decades and countless person years of experience of all programmers that have gone before, and it's all lost. And so in my mind, it's very valuable to understand how to program in primitive languages, because then you understand the value of less primitive ones, and you understand and you remember, you realize what the origin of global variables are bad actually is, and how it's applicable today, and whether or not it's applicable today. So let's go back in time to the basic programming language. Probably nobody programs in BASIC anymore, but that means that actually fewer people dabble in programming. Back at the time when BASIC came out, all kinds of people that you wouldn't think would be interested in programming programmed, because it was so easy to get into it. You think about it now on your computer or your devices, it's virtually impossible to easily program. And if there is a sort of an emulator of these early systems or BASIC or whatever, people get frustrated because of the user interfaces, God knows what. But back then, it was exciting and people did it. And the excitement has gone. So I think it's important to think about what made it exciting, even on those early underpowered computer systems. And what it was that it was responsive. You did something, you tried it, you got an immediate result. And BASIC was pretty good for this because there was no compile time. And, it was a very strange thing, though. The editors for these systems were often not like editors as we understand them now. Every line had a line number, right? And so you could access any line in your document with a number. Oh, it's so primitive. But you have to think that actually had some advantages, because that meant if you remembered that your subroutine was on line 999, you could very quickly get to it. Well, you could say you can do that now. It's true, I guess. Anyway, the thing was, it was very immediate. I'm kind of digressing. But the thing about these the basic programming languages is that they used global variables. Because it was such a simple programming language, it did not deal with or include certain concepts from the developing field of computer science. Things like scope. So with scope, it basically means you define a variable and then that variable exists only in a certain region of your code and can only be accessed in that region. So this allows you to keep variables separate from each other, private. It's actually a form of privacy that was there from very early programming languages as soon as they had this concept of local variables in a scope. So the C programming language and languages like Pascal would have these things, obviously. But BASIC didn't. The only thing BASIC had was global variables. So when you programmed, at least the original versions, so when you programmed in these languages, you quickly found out that, you would introduce bugs because of problems such as you have a for loop inside a for loop and you ended up using the same variable for both. Or even worse, you have a for loop with an I variable that you call I, and in it you call a subroutine. And in the subroutine it modifies I. And so the subroutine causes the for loop to break. These things are obviously bad, right? So to get around this problem, there was the idea of scope. And this fitted in very well with computer architecture through use of a stack. The stack that was used to hold the return address of any function or subroutine that you executed. It could also be used to store local variables. So that became something that happened too. You use the stack to store not just the return address, but also the local variables within a function. And in this way, it was possible to have local variables. Now, this is all going back to a time of BASIC and C and Pascal and those early languages, but C survives to this day, as in is used everywhere. Or C or C++. C is still everywhere. It's basically the Linux kernel is written in C, So, but the principles are the same. And what it means is that you have local variables, but the early basic programming languages didn't have didn't have local variables, only global. And so from this, you learned that global variables are bad. This is the actual origin, yes. In fact, if you want to be more strict about it in our language, we would say that what's bad is not having scoped variables. That is not possible. That is, if you are not able to call a subroutine and that subroutine or function, and that function is not able to have its own copies of local data that it needs to use, then that's bad. And voila, global variables are bad. The problem is that everyone's forgotten that this is actually the reason why global variables are bad. Now, if you could do a little experiment, is you go onto the internet and you ask the question, why are global variables bad? And you won't get a clear answer, because everybody's forgotten. What happened as a result of this moth, a moth of programming, is like a myth. But, with a myth, it's really, a myth is usually tend to mean something that isn't true, or a story that isn't true. But in fact, the origin of the word myth is a word that we use, or a concept we use, to make sense of the world. So a myth is more than just something that isn't true. Myths are actually useful. But moths, but you must remember that they are myths, right? But moths, in terms of what, moths are not useful at all. They get in the way of your thinking. Either they are concepts which, actually, my definition of a moth, a programming moth, will be something that started out as having some kind of meaning, and then it evolved from the larvae into the moth, and then it flutters around in your head. But the point is nobody actually remembers where it came from or why. You see, so a programming moth will be something that grew in the collective consciousness of programming, if you will, if you call it like that. But it doesn't really have any connection with any more with what it was. And as well as that, it's very distracting. So we take global variables as a moth of programming. We need to see what happened as a result of this problem. So where programming went from there was that after this idea of being able to sort of have local variables, which was great, there was a problem. The problem was that you still need global variables. So, because not global variables, you need state which persists outside of all your functions. Right? That is needed, and that needs to be organized. So the organization of this data that your functions work on is a big task in the design of computer programs. You have to think about where you store your data and how you store your data. So the way that was done with early programming languages, and is still done with C, is that you can create a block of memory and say, these bytes here are going to be, say, the age of the person. This is a record of a person, let's say. So we'll have the age, that's going to be an integer, let's say, or we could have their height, which is going to be a float, and we could have a string, which is, strings. But anyway, string, which is the name, would be a pointer to a string, I presume. And so on. And then what you do is you would allocate some memory, and then you have to remember where you allocated the memory, and then you have to you can use that block of memory for that particular person in your program, and voila. So that was the next evolution. And in fact, it's not actually that much of an evolution. You would do the same thing even programming in assembler, in effect. So that was all great. And the problem is that people started looking at the issue that we would get, the issue that you would get with this is that it quickly became unmanageable to deal with all of this memory. Plus, on the early systems, there wasn't really any protection, and it's still true in C++ and C programming now. So it means that you could have a bug that would wipe out your global, your data. Okay. And then there was the fact that you had to put that data somewhere that is accessible by everybody, and so you make it global. But the problem here is that there's this perception that global variables are bad. You see, because as we go through the years, people are forgetting that why global variables were bad. And the actual reality of global variables was replaced with just a rhetoric. And this caused people to want to avoid using global variables at all. So that's how we've ended up in C#, with not being able to create any global variables. But there are other reasons too. But, there are no globals in C#. There are only statics. You see, they don't call it global, it's called a static. You might wonder, why did they not call it global? Well, it's because global is a kind of taboo. But it is a global. You have a static class, it's a global class. You have a static class with a member in it. It's a static, it's a global member. It's accessible from anywhere. But we're sort of coming out of this phase now a little bit, but it's really taken its toll. This desire to avoid global variables was taken too far. So you can see this in various architectures developed, say, with that horrible language C++. I wasn't always so negative towards C++. And I have become very negative towards C++, which would be a topic for another day. But when you look at what you typically find when you combine the cocktail of C++ and object-oriented programming and a fear of global variables, then you end up with this nightmare scenario of you're always having to remember where you remember. You're always having to remember. I mean, look, it's like you connect things together with pointers. So you have an object and it needs to point to, say, that's the name of the person in a record. It's like the name. This is talking in C and C++ here, same in other languages under the hood, is you have a member of a struct or a class and it points to the name. So, well, that's fine. So you allocated memory for the name and you remember where that is because you put a pointer to it in your struct. Now you allocated memory for your struct. And you have to remember where you put that. Maybe that's inside some other object, like a database. Then you have to remember where the database is. You see? And so, if you try and avoid using globals, eventually you end up with a twisted architecture that in the end uses globals, because they're unavoidable. The globals are unavoidable. But we all think we're not doing global. What do you think happens when you do new on a constructor in C? It's a global call. Oh, shock horror. Yeah, it's like you do new. It's calling a static the constructor is a static function in effect. There's this kind of the language, you put an U in front there, so there's some kind of syntax from the language, but it actually maps in the end to it's a global function. And in fact, there's many cases when, for reasons of the problems of C++, you actually don't use that at all. And in fact, what you do is create a static method that returns an instance. That would be is it a factory? I suppose you could call it a factory. It's the class just has a static function that you call to return a new instance. It's like very common to end up doing that because it's more flexible. I mean, now you don't use the word new anymore. New memory allocation is global. It's all everything is global all the time, and we try and pretend it isn't. So, of course, the final result of this is that we end up with the most horrific thing ever invented, the big behemoth. If you pardon the pun. The Singleton. The Singleton is the ultimate manifestation of the fear of global variables. Because what a Singleton basically is a static global class that pretends not to be. Almost like, well, we don't like to think about this, guys, but, it does turn out that we've only got one keyboard, one input module. Well, we've got one input module. And, we've been trying really hard to avoid having any globals. But it turns out we need to remember where we put the damn thing, the input module. So what we've done is we create, because, globals are bad, right? But, there's nothing we can do. At some point, someone has to remember where the hell we put the thing. So we're going to just sort of bend a little, and we're going to create a global variable. And this global variable will contain a pointer to the instance of our input module. And there is much cheering. Hey, hurrah! And we shall call this pattern the Singleton. Huzzah! Hooray for the Singleton! Yes. That's right, great. So, what we've got there is a whole journey that has just been taken in computer science, where we went from global variables are bad, for good reasons in BASIC, into a language where those reasons are not relevant anymore, but everybody's afraid of global variables. So we create an input module that is an instance, but we only have one of these instances in our application, and then we put that in a static variable, and now we can access the single instance of our module, class, our object, our what? It's like, why not just not have an instance in the first place and make all the data that you have for your input module and all of the methods or functions that you use for your input module, and you just make them global? Because then, well, there's nothing really to go wrong, is there? What can be bad about that? It's like, you need to read the next key press. You might as well just have a global function to get the next key press. And but no, there you are. You wrap it up, and so you objectify it. You see, you take that global. So it's like global variables are bad, but singletons are great because singletons have sort of cleaned up, let's say, made, sanctified, disinfected, let's say, the concept of the global. But in the end, it's just a global. And it's terrible. This thing is terrible because it turns out, which will be the topic of another time, but it turns out that global variables are great. They are wonderful. But it's like anything. There's the right place to use things, the wrong place to use things, and all the rest of it. So it does also depend a little bit on context, right? But they are wonderful. Well, after you spend decades trying to avoid them, you realise that they are, in fact, the silver bullet. And if you don't believe me, I will leave you with this thought. We have on this planet a gigantic connection of millions, billions of devices all running software all together at the same time and able to communicate between each other through the internet. And how do you access the data on someone else's computer, presumably if you've got permission? You use their address, the name of their computer, or the IP address. In the end, it becomes an IP address once it's resolved. The name resolves to an IP address. It's like a telephone number. You know? Well, that's global. If you imagine trying to object-orientate the internet, how would that work out? I don't think it will work out very well at all. Because in the end, you don't want to have to remember where something was put. What you want to do is access things by name. And accessing things by name is, in fact, the silver bullet. Because when you access things by name, you can organize stuff, and you never lose anything. And you never have a problem that, it's moved. Because that's the classic one. You hold a pointer to some data, and for some reason that data's moved in memory. And now you've got an old pointer to it. The pointer's pointing to something invalid. It's a classic problem, right? But it's not a problem if you access everything by name. And what is a name? It's a global accessor. Global variables are brilliant. How did we miss this?
I hope you enjoyed this podcast. Watch out for future chapters in the series.